In 1966, the United States had already tried something similar. The project was called Mohole. Instead of drilling from land, American scientists wanted to drill through the ocean floor and reach the Earth's mantle. The idea was revolutionary, but the project ran out of money and was abandoned. A few years later, the Soviet Union decided to try something different. If the Americans wanted to go through the ocean, the Soviets would go straight down from land. The location they chose was the Kola Peninsula in the Russian Arctic. The choice wasn't random. Ancient rocks were exposed relatively close to the surface. That meant the drill could reach geological material billions of years old without first passing through enormous layers of younger sediment. On May 24, 1970, drilling officially began. The original target was around 7 kilometers. That already sounded extraordinary. But the project soon grew much more ambitious. A new drilling system was developed specifically for the mission. And eventually the target became 15 kilometers. At the time, humanity had better maps of the surface of the moon than it had of what existed just a few kilometers beneath its own feet. The Soviet engineers were about to change that. Imagine standing beside the drilling tower in the Arctic. The wind is freezing. The ground is covered in snow. And beneath your feet is a hole barely 23 centimeters across. That's roughly the width of a dinner plate. But that tiny opening extends downward, kilometer after kilometer. The challenge wasn't simply drilling deeper. The deeper the drill went, the harder it became to control everything above it. A conventional drilling system would require the enormous column of pipes to rotate from the surface, but at several kilometers long, that became impractical. So the engineers developed a different approach. Instead of rotating the entire drill string, they used a turbine near the bottom. Pressurized drilling mud flowed through the pipes and powered the turbine. The drill bit rotated down at the bottom while the enormous pipe above it remained comparatively stable. It was an ingenious solution. And at first, it worked. The first several kilometers went surprisingly smoothly. The rocks behaved roughly as expected. The deeper they went, the older the material became. But around 7 kilometers down, something happened that changed the scientific value of the entire project. Scientists had expected a major geological. Based on seismic measurements, they believed that around this depth they would encounter a boundary between different types of rock. One popular interpretation suggested that granite would give way to basalt, but when the drill reached the predicted boundary, there was no basalt, there was more granite. Not exactly the same granite as above. It had been fractured and transformed by enormous pressure, but it was still granite. At first, this looked like a failure of geological theory. But the reality was more interesting. The seismic waves had not necessarily been wrong. The problem was how scientists had interpreted them. For decades, Earth's interior had largely been studied indirectly. Scientists could not see through kilometers of rock. Instead, they relied on seismic waves. Those waves travel through the planet and change behavior when they encounter different structures. The Kola borehole showed that those boundaries could be much more complicated than the simple layers shown in textbook diagrams. A seismic boundary did not always mean one type of rock ends and another begins. Sometimes it could represent changes inside the same rock caused by pressure, fractures, and mineral transformations. The deeper they drilled, the more obvious it became that the Earth's crust was not the neat, layered structure scientists had imagined. It was far more complicated. And then they discovered something even stranger. According to the models of the time, deep underground rock should have been almost completely dry. Pressure was enormous. The rock had been buried for billions of years. Any water near the surface should have disappeared long ago. But the drill cores told a different story. At several kilometers below the surface, scientists discovered water inside deep fractures in the granite. This was not simply rainwater that had slowly leaked down from the surface. The geological evidence suggested that the water had become trapped deep within the rock. It was chemically different from ordinary surface water. It was loaded with dissolved minerals and had existed in an environment completely isolated from the atmosphere. And this discovery had implications far beyond the Kola Peninsula. Because if water could survive deep inside Earth's crust, then perhaps similar environments could exist elsewhere. Mars. the icy moons of the outer solar system. Other worlds where liquid water might exist beneath layers of rock or ice. The drilling mud also revealed something unexpected. Large quantities of hydrogen were detected, along with other gases including helium, nitrogen, and carbon dioxide. The deep Earth was not simply a dead block of rock. It was chemically active, and then the scientists discovered something even older, something that had once been alive. Researchers examining rock cores extracted from several kilometers underground discovered microscopic fossils. They belonged to ancient single-celled organisms. Some were estimated to be nearly 2 billion years old. These organisms had not lived kilometers underground. They had once lived near the surface of an ancient ocean. Over geological time, the rocks containing them had been buried deeper and deeper. Eventually, they ended up kilometers beneath the Earth's surface. The remarkable part was that traces of organic material had survived the enormous geological journey. It demonstrated something important. Ancient biological material could survive much deeper underground than scientists had previously assumed, and that raised a much bigger question. If traces of life can survive for billions of years inside Earth's crust, what could be hiding beneath other planets? Today, scientists know that a huge portion of Earth's microbial life exists underground, far below forests, cities, and oceans, in cracks, inside rocks, around deep sources of chemical energy. Life does not always need sunlight. Some organisms can survive using chemical reactions occurring deep inside the planet. The surface of Earth may look like the main stage for life, but biologically speaking, there is an enormous world beneath it. And the Kola borehole gave scientists a rare physical glimpse into that world. But eventually, the deeper they went, the more dangerous the environment became. In 1979, the Kola project broke the previous depth record. The drill reached approximately 9.583 meters. For the first time, the deepest artificial point on Earth was no longer in the United States. Kola held the record. Then the drilling continued. In 1982, the project passed 11 meters. The target of 15 kilometers suddenly seemed within reach. But there was a problem. The deeper they went, the hotter it became. Scientists had expected temperatures around 100 degrees Celsius at those depths. Instead, measurements were approaching 180 degrees Celsius, and that difference was catastrophic for the machinery. At those temperatures, the physical behavior of the surrounding rock changed dramatically. The rock no longer behaved like a rigid block. Under immense pressure and heat, it became much more plastic. The deeper they drilled, the more the Earth itself seemed to fight back. And then came one of the biggest failures in the project's history. In 1984, after reaching more than 12 kilometers, the drilling string failed. A huge section of pipe broke deep underground. Around 5 kilometers of pipe became trapped inside the borehole. It couldn't simply be pulled out. The engineers had lost a massive amount of equipment. The solution was brutal. They had to retreat. Instead of continuing from the existing hole, they went back to around 7 kilometers and started a new branch. The Kola borehole wasn't really one perfectly straight tunnel anymore. It became more like an underground tree. Multiple branches extended from deeper sections. Each branch represented another attempt to go farther. Every failure became part of the history of the project, and every recovery operation could take months or even years. The engineers developed specialized tools to retrieve broken equipment. These operations became known as fishing trips. The goal was to descend thousands of meters, grab a lost drill component, and bring it back to the surface. Sometimes the process worked, sometimes it didn't. And one recovery operation reportedly lasted for years, but the engineers kept going. Eventually, they reached the number that would become legendary. The deepest successful branch reached approximately 12.262 meters. That's more than 12 kilometers straight down. But here's something most people don't realize. The number isn't simply the length of one giant empty tunnel. The Kola project developed several branches, and the record depth belonged to one particular branch. At that point, the engineers had pushed the technology of the era to its limits. But the real enemy wasn't the depth itself. It was the combination of heat, pressure, and unstable rock. Every time the drill was removed, The surrounding material began to deform. The borehole could partially close. The deeper they went, the more difficult it became to maintain a passage. It was almost as if the planet was healing the wound they had created, and the machinery was suffering too. Drill bits wore out, pipes deformed, high temperatures destroyed components, and eventually, the original 15-kilometer goal became unrealistic. The Soviet engineers had reached a depth that no human had ever reached vertically. But they had not reached the Earth's mantle, not even close. And the discoveries didn't stop with water and ancient fossils. Deep inside the rock cores, scientists also found evidence of gold-bearing zones. A substantial interval of rock contained elevated concentrations of gold. But this wasn't some underground treasure chamber. There were no giant veins of pure gold, and some of the spectacular numbers that circulate online are simply exaggerated. The reality is much more interesting. The gold existed within the rock itself. To extract it economically would require enormous quantities of material to be processed. At that depth, bringing anything to the surface would be an engineering nightmare. So the gold stayed where it had been for millions of years, deep beneath the Arctic. Another reminder that the Earth's crust contains things we barely understand because we've barely scratched its surface. By the early 1990s, the project was running into a problem that no drill could solve: money. The Soviet Union was collapsing. The scientific project lost funding. In 1992, one branch stopped at around 11.882 meters. Another attempt later reached less than 9 kilometers. But the original mission was effectively over. In 1994, drilling finally stopped. The scientific team was gradually dismantled. By the 2000s, the station had become abandoned. The equipment deteriorated. Buildings were left to the Arctic weather. Snow covered the site. Rust replaced the machinery. And the world's deepest vertical borehole was left behind. But the engineers still had one final problem. They couldn't simply leave a 12-kilometer shaft exposed, so they sealed it. The final solution was almost absurdly simple: a steel plate, bolted over the opening. A tiny metal disc covering a hole that reaches more than 12 kilometers into Earth. The plate wasn't hiding a secret, it was there for safety. The borehole was only about 23 centimeters wide, but it was still a deep, abandoned industrial structure. The site had to be secured. Today, the former Kola drilling station is largely a collection of abandoned structures and rusting equipment. The enormous scientific ambition of the project is difficult to imagine when looking at the site now, but beneath that small steel cover, the borehole still exists. And somewhere below it are thousands of meters of geological history. And then the strangest chapter began. A story appeared claiming that Soviet scientists had lowered a microphone into the hole. According to the story, they recorded screams, human screams, from what they supposedly believed was hell. The story spread rapidly. Religious publications repeated it, television programs repeated it, and eventually millions of people heard about the mysterious Soviet scientists who had supposedly drilled into the underworld. There was just one problem. It was not true. The story contained multiple contradictions. The location was wrong, the depth was wrong, the scientists were fictional, and the famous audio recording was not a recording from the bottom of Kola. It was linked to a horror film. The story was eventually traced back to a Finnish Christian publication and later amplified by American religious television. At one point, an individual even deliberately supplied fabricated details to test how easily the story would be believed. It worked. The myth became more famous than the actual scientific discoveries, and ironically, the real story is far more fascinating because they did not find demons. They found something much stranger. They found a planet that behaved differently than expected. So here is the obvious question. If the hole still exists, why do not we simply lower a camera into it? The answer is the environment. At the record depth, temperatures approached 180 degrees Celsius. Pressure was extreme. The borehole was extremely narrow, and the surrounding rock was deforming. A conventional camera system would face enormous engineering challenges. Even if you could build electronics capable of surviving the heat, you would still have to get them through a narrow, unstable, kilometers-deep passage. And there is another important detail. The deepest point humans have drilled vertically is not necessarily the deepest artificial path ever created. In 2008, a well in Qatar reached more than 12 meters of measured well length. But the well was highly deviated. It traveled far sideways. The Kola borehole remains the landmark record for vertical depth. That's an important distinction, because drilling straight down is an entirely different engineering problem. For decades, Kola seemed untouchable. Then new drilling projects began pushing toward the same frontier. In 2025, China completed a borehole reaching approximately 10.91 meters. It became one of the deepest wells ever drilled on land, and suddenly, the old Soviet record looked less unreachable. The remaining difference? About 1.35 meters. But those final kilometers are the hardest. At extreme depths, temperature rises dramatically, pressure increases, rock becomes more difficult to control, equipment suffers, and drilling speed can collapse. A few hundred meters near the surface can be relatively easy. A few hundred meters near the deepest point on Earth can take months. China's project demonstrated exactly how difficult this frontier remains. The final portion of the hole took an enormous amount of time. And that is why breaking Kola's record isn't simply a question of drilling deeper. It's a question of inventing technology capable of surviving the environment. There are even ideas that don't rely on traditional drill bits. One experimental approach uses extremely high-frequency electromagnetic energy to heat and break rock. Instead of grinding the rock away mechanically, the system could theoretically melt or vaporize it. The advantage would be enormous. No conventional drill bit, no mechanical cutting surface constantly wearing away, and potentially much greater resistance to extreme temperatures. But these technologies are still far from replacing conventional drilling at kilometer-scale depths. The deepest experimental demonstrations remain tiny compared with Kola. The problem is scaling. It's one thing to vaporize a few meters of rock in a laboratory. It's something completely different to create a controlled borehole more than 10 kilometers deep. Still, the technology is evolving, and the motivation has changed. This isn't just about national prestige anymore. Deep drilling could provide access to geothermal energy. It can improve our understanding of the Earth's crust, and it can help us understand where underground resources are located. The race downward has returned, but this time, the prize isn't a flag, it's knowledge. Now step back for a moment. Imagine shrinking Earth down to a sphere only 1 meter across. The deepest hole humans have ever drilled would be little more than a tiny scratch on that miniature planet, a fraction of a millimeter. After more than 20 years of drilling, after thousands of workers, after millions of dollars, after broken drill strings, extreme temperatures, and countless engineering problems, humanity reached only a tiny fraction of the distance toward the center of Earth. Kola did not even penetrate through the entire continental crust. It barely scratched the outer shell. We have mapped the surface of the moon in extraordinary detail. We have sent spacecraft beyond the solar system. We have landed robots on Mars. And yet, we still know remarkably little about what lies just a few kilometers beneath our feet. That is perhaps the most astonishing lesson of the Kola project. The deepest hole in human history was not a tunnel into the center of Earth. It was not even close. It was a tiny wound in the planet's surface, and Earth slowly began closing it. Today, that small steel plate remains a symbol of one of humanity's most ambitious scientific experiments. Beneath it lies a borehole only about the width of a dinner plate, but more than 12 kilometers deep. Inside the rocks extracted from that hole are clues about ancient oceans, ancient life, deep underground water, and the strange physical behavior of our planet. The Soviets wanted to reach 15 kilometers. They stopped at 12.262, not because they ran out of curiosity, but because the Earth became too hot, too unstable, and too difficult to drill. And perhaps that is the most fitting ending. Humanity spent decades trying to force its way downward, but eventually, The planet won. The rock became soft. The equipment failed. The hole began to close, and the machine stopped. The deepest hole humanity has ever made is still only a scratch. So here is the question. How long do you think the 12.262-meter record will survive? Because thousands of meters away, another drilling project is already getting closer, and the next attempt may not come from the Soviet Union, but from China. Subscribe to Source Code, because next time we are going back underground, and we are following the new race toward the deepest point humanity has ever reached. See you in the next one.